Hello, everybody. Welcome to another Jakarta Tech Talk. Joining us today is Chad Carlson from Platform.sh, presenting GitOps keeps focus on product, not on infrastructure. Chad is a DevRel engineer from Platform.sh and an all-around experimenter. Outside of work, you can find him writing, cooking, or trying to learn yet another programming language. Without any further delay, let's turn it over to Chad and discuss how to spend more time developing products and less time managing complex infrastructure. Chad, it's all yours.
Thank you very much. Hi, everyone. My name is Chad Carlson. Thank you very, very much for having me. Title of my talk is GitOps keeps focus on product and not on infrastructure. I'm hoping to get across some of what we do at Platform.sh and how it might help you with your Java projects. Sorry, a little tongue-tied already to start. As we go along, I'll have some slides that sort of cast what part of the problem we're trying to solve is, along with some screen capture of working with some actual projects. So I'm going to try and get that timing right as it's all edited together. So let's go ahead and start. Here's a picture of me. As I was introduced, I am a DevRel engineer at Platform.sh. Most of the time I work on our public documentation, also our template and example projects, and a lot of blog posts and writing about what it is that we do at Platform. And one of the main ideas that we try to get across is this idea of GitOps, which you could be familiar with at this point. And the main approach that we try to take with your projects and this idea of GitOps is Git being the source of truth. So if we have a project, we want the code describing that application to be committed, obviously. We want to leverage Git in everything that we do. But another component of that is leveraging Git that we're already using to define things like what does our infrastructure look like? And can that be version controlled and environment and branch dependent in the same way that a piece of code can? And so that's what we try to apply at Platform, where Platform is a service provider. You don't have to deal with the configuration on some of these big infrastructure service providers, and we provide a level of abstraction by which you can abide by this infrastructure as code idea to include definitions of your infrastructure as part of your code base, along with the code itself, all the definitions of your dependencies, so that as you create new environments and you go through whatever pipeline you defined, you have this final build image that is defined for that environment and can be passed around to production when you perform your merges. So it's a lot of extra visibility, and it's a lot of increased dependability and repeatability that comes from this approach. And something that we like to address is at the end of your build, which I'll show in a little bit here, because we have infrastructure, code base, and dependencies all defined into this final build image, when we merge something into production, it's going to be that identical build image that you're actually deploying to your live site and to your domain. So there's that extra assurance that nothing's going to break when you do make some sort of change because you've already built that image. So that's some scattered details maybe on the GitOps concept, but in general, the way that we like to think about it and seen it defined elsewhere, obviously, is Git acting as the source of truth to sort of implement what I'm talking about. It's the place where we take what's already good about Git and use it as a way to control environments, how they're created, how they're destroyed, and what kind of information is isolated to or inherited into these environments. And then it provides a place where all of these changes can be observable and verifiable. So obviously you're going to have some commit history where you can see exactly who made what change, where and when for which commit, but we can extend that same concept as we use it to build out our pipeline to do things like who triggered which activity when, which can be a push or it can be a environment variable setting event. All of these things get tied into hooks and an assortment of other tools built on top of Git that we're already all using. We'll come back to this a lot, but let's go into maybe a more defined example. Okay, so let's say that I'm running an agency. The example here is WordPress, but I kept this example just because part of what is interesting about how Platform does what it does is that it supplies a lot of support for a variety of different runtimes. And it kind of doesn't matter what it is that you're running. You're running a Java application. We have a number of Java runtimes, PHP, Node, Go, whatever it is that you might need, whether it's for your principal app or you're trying to create something a little bit more microservices oriented. You have this wide selection of runtimes for it. And in this case, let's say I'm running a WordPress agency, but some kind of agency. And I have lots of sites and I'd like to handle a lot more. Obviously, I want to build my business as much as possible. That'll be good for the recording. So what kind of workflow do I need to have? I need to be able to expand and add more sites at will. I need to be able to keep each of these sites up to date and potentially in sync with a common repository that defines the same application across all of them. I need to have strong testing as a part of my pipeline for each of these sites. And I want to be able to quickly test changes that adding or updating a dependency or to, as we'll see here with Platform, changes to my infrastructure will make on all of those sites. And I need a quick way to create new environments for both internal and external collaborators. It makes sense that I want to be able to delegate an environment for one of my developers that is doing something, but I also very well may want to create an environment for some external agency to do some design overhaul on the front end of my site. So I would like to be able to have that kind of flexibility. Like I said, I want it to be able to keep up to date with whatever I have as this template upstream for each of my sites. If it's a WordPress agency, WordPress fleet that I'm issuing out for all of my customers, I need a quick way to be able to only really focus on developing an upstream, but each of these sites be able to get those updates when they're made. And then I'm talking about lots and lots of sites, and I need a way to manage this fleet of applications that have very similar characteristics, whether it's this upstream or it's a collection of environment variables that each of them are going to require, whether when they're initialized in the first place or long-term day-to-day secrets that they need in order to run. I need to be able to sort of manage them on a larger scale of directing and controlling how this fleet operates. So how do I do that? I could learn the configuration and build up this large DevOps tooling around this problem set using things like Kubernetes and Docker Swarm and Circle CI and a lot of integrations to get pretty close to this ideal. But of course, I mean, none of those are non-trivial tools to learn in the first place. So you're going to have potentially expensive developers that you're going to need to hire who are very knowledgeable on one of these and hopefully extremely knowledgeable on all of them so that you can keep your workflow going and nobody gets in anybody's way, that it's not a difficult task to apply updates to one or N sites across that fleet, or for you to do, like I said, the task of having a particular site in isolation, a single site, and have the kind of single tenant control to be able to create a testing server for an external agency to do whatever they need to do design-wise on that site. So that's configuration, tooling, time, maintenance, and expensive technical know-how to cover each of these tools to create this kind of GitOps pipeline. Just going to let it play right now. So instead, with Platform, we can sort of abstract away a lot of that. Git acts as the source of truth. We have everything visible and everything is tied to these environments. So we allow Git to control how environments are created and destroyed. And it's where we observe changes in our infrastructure. And we'll see some examples of what that configuration looks like in a second. But everything gets committed alongside the application itself inside the repository, because it becomes just as much a part of the app as the code itself. So this is minimize this quick. We have a post on our blog that I'd be happy to share the link with in the chat from my colleague Larry Garfield about this topic that I would really recommend taking a look at if you're interested in what our approach is in particular, and there's any gaps that are still left over from this talk. But the end result of all of this, the desired result, is folding all of the buttons and dials and switches and know-how that control the application, the environments, and even scaled up even more to this fleet of site to make a change on Git, on a branch, commit and push, and everything is sort of taken care of with a reasonable level of visibility that comes with it. So you don't have to build any of this pipeline yourself. So let's see what that sort of looks like in progress. Let's see what that looks like in practice. So here I have a WordPress site, again, that is on my own GitHub account. This repository is tied to a project on Platform.sh. So on that repo, we only have a master branch. On the project, we have only a master environment that shows that front end site right there. It shows my WordPress site. And so it's mirrored on that production environment. We can make a change to our code base and open a pull request, and that'll result in an environment automatically being created on the project itself. Now, since we're relying on Git, our branch is going to inherit a lot of configuration that defines the infrastructure for this WordPress site. So in this case, it's going to be what version of PHP, what version of the database, all of that's already committed to the repository. So it's going to be an exact copy on this new environment. And so what this environment really is an exact copy of what we had in production, but it's going to be an exact copy of our infrastructure in a totally isolated environment from master or any other branch or pull request that happens to be open. So let's take a look at some of this configuration file, because it can be a little bit more clear when you see that. So what I'm building is a collection of containers that define a virtual cluster for my final site. It's a WordPress site, so I'm going to have a PHP container. Well, which PHP? In this platform app YAML file, I'm going to define everything that has to do with that PHP container. It's going to have a name that allows me to define how traffic comes into that container and how other containers in the cluster communicate with it and what they can see, if anything, of that application internally. I'm going to say what runtime it's going to use. So in this case, it's PHP 7.4, but this could be, like I said, pretty much anything. If you go to our Java documentation, you would simply substitute that type key with a Java :14, just like is right here. And then that would give you Java 14 as your principal runtime in this application container. And same goes for Go, Python, Node. We even have an Elixir container. And then after that, we are going to define how the application in this container is going to be built and deployed. So this is a fairly simple app YAML file. There's not much included in its build step because we are relying on the dependency definition. So in PHP, we're going to rely on Composer as our package manager. And so our containers automatically detect that there's a composer lock file inside our code base. And so as its first step in build, it's just going to run composer install on that. And for this composerized version of WordPress, that's going to situate our entire non-committed file structure for WordPress core and any of the plugins and themes that we want for that framework. I have an example here. Here it is. Here's a lot of the templates that we usually share with people of how to run different applications on platform. So it's just an organization that's filled with almost 100 templates for different languages. And here tabbed out is the Java templates. If I go to the Pyre micro template, I can look at this same file. And as I described, I can have a Java 11 runtime on here and define how I want to build that image from my code base. And then if I want, I can have separate deploy hooks and post deploy hooks here that represent the three major web hooks that would replace what you would normally be used to describing as these build jobs for your application in some other DevOps configuration. I think that that's all I have on here. We can go back to that sample in a second. But I think you could probably see at this point that this is where we start building a lot of the assurance of our builds being completely repeatable across environments, because our infrastructure is a committed thing, just like the rest of our code base. So any branch I make is going to continue to have a PHP 7.4 or a Java 14 runtime on it. In the same way that I have defined what my dependencies are, it becomes a dependency of the application in the very same way. That then, if I place on GitHub, gets tied to every single new environment creation. It's also within this build hook here that I can include any of the testing, my entire testing suite that I might include in something like Circle CI as a part of my build hook. So if you wanted to, you could have tests in your build hook, your deploy hook, and post deploy hook that are conditional. If they fail at all, then the application won't deploy, and you can limit merges to those that actually do complete all of these steps for every single build that you execute here before you merge anything. Similarly, well, I guess we can go through some of these other parts of the file. Am I going too fast for anybody? Let's see, we got the ask the question here. Hi, Matthew. Well, before we go into that, we'll do this. We'll go back to the Pyre example. So that is an app container. It's got a runtime, build, deploy, and post deploy hook. Other than that, included in this file, we have a start command that runs right before the deploy hook. So in this case, we can set things like memory limits and which port to serve the final jar file on. Other than that, I guess the other important concept to consider how it ties into this GitOps idea is that by default, you can do anything you want during the build hook, but then as soon as start command deploy hook onwards, your application is going to exist on a read-only file system. So it becomes interesting because we've certainly come across a lot of applications that expect a lot of write access at runtime. And it isn't that you can't define something like that. I think even inside here in the WordPress file, I know that there's some not the best way to navigate. But anyways, you can define mounts inside your application for places where you do need write access. But these aren't things that are included in your repository. They're not things that are ever committed. So they become pieces of data that never travel up to production. Alternatively, when I create a new branch, I was saying that you get all of your infrastructure configuration and your code base in any of these child branches, but we treat data as going in the other direction in this case, as sort of an extra piece of tooling on top of Git. So yeah, you inherit infrastructure and code, you inherit everything that's committed, but you're also going to inherit all of this production data, which can come in real handy if you do plan on extending out your build hook to include a series of tests, because you can run those tests on pretty close to live production data without having anything to do with the production site, without ever touching it. It's still being completely isolated. I think here's just a screen capture of me closing that environment, resulting in the same thing in the opposite direction. I can create new environments based off of what I have committed in my repository, but it also controls how things are destroyed. Here is exactly what I was talking about, that if I change something on a branch, inside that repository, I have code, infrastructure configuration, and dependencies that all become a final build image associated with the tree ID for Git. And so what we end up being able to do is anytime that we merge something into production, we essentially reassign that tree ID to master and reuse the build that we already made. There's no new thing that can be that can act unexpectedly when we finally merge into production. And I think that this is where expecting a read-only file system really becomes an important point, because we have generated lock files, we have infrastructure committed, we have all of these things that rely on us trying to put together this final environment independent build image that we can kind of pass along and maintain the sort of assurance on top of Git that merging is not going to have something unexpected, branching is not going to have something unexpected, and data is where we expect it to be. And so this is sort of where we would see it here in the steps of our tooling. That is how we do configuration for application containers. So every project sort of gets these three main files: this app YAML file, a routes YAML, and services YAML file. So the same way that we define which version of PHP that we want, we can define the exact major version of MariaDB that we're going to use as our primary database in this services YAML file. And we can determine how much disk it gets allocated to it. And if you'll see, we give it this service name DB. It becomes how our WordPress application, you'll see right here, we have something that's called a relationships block that defines the internal network of our final project. So while everything's committed, this is where we can actually do some communication between our services. So here's our DB service, and to our application, it's going to be accessible from this database name, this database key here. And everything ends up being isolated but also environment independent, like I said. So we have this generic, it ends up being database.internal, from which our database is accessible, but we don't need to know the exact host, because that's going to be different between every environment. We don't need to know the exact environment either. or the exact password either. These aren't values that any of our developers really need to know. And there's something that can vary between environments while still connecting to the same infrastructure. And so we can do that through our environment variables and our expectation of, hey, we've committed this name for the relationship. So it can really be something that travels across our whole project. So in this screen capture here, all I'm showing is, hey, we've created a new branch. We want to test the new version of MariaDB. I can go into this services YAML file, change that single character from 4 to 5, push it up into a new branch and open a pull request, and I get a brand new environment that can test out that change. It's isolated with this byte level copy of all of our production data. So it's actually going into that new version of the database so that I can verify that, hey, things look good. I'd like to be on the newest version of MariaDB. Our real data is inside of it. It's passed all of our build tests and working with that data. I'm feeling pretty confident. So I think here in this screen capture, I'm just showing that I have a generated URL for master on the left, and now this pull request that I just opened that contains the same content that was stored in the database between my two environments. So that comes in handy when we're doing all the tests. And so this services YAML file can be extensible to continue to build out our virtual cluster. So I have just a database here now, but I can add Redis with just a new service name here at 6.0. And what's the next one? I think it's Elasticsearch. Yeah, so I can add an Elasticsearch service too, and it just adds another container to our cluster. And so long as we define a relationship in our app YAML file in our application configuration, each of these services now become accessible so that we can modify our application code, our actual code base for the site, to start using these services very quickly. There's no add-on process or anything like that. It's just simply branch, do the services YAML, and it becomes a part of our commit history, just like any changes in our code. New infrastructure with that change. Same goes for dependencies. Run your composer update, run your update command for Maven, and then you get a new environment to test out those changes on. I think I've always been curious, what's the prevalence of like this decoupled conversation in the Java space? I know when I become more, where I've been more familiar with it, obviously, is it's a JavaScript type of thing. People are really interested in doing a JavaScript front end, but it's a lot of PHP applications on the back end. You know, are there any real popular Java CMSs that people are interested in doing this decoupled pattern with? If anybody does know, please just leave it in the chat. But one thing that we can kind of build on this idea of adding additional service containers in this way in our services YAML file, we can do the same thing with the structure of our code base itself. So I can take that original WordPress site and I can place it inside its own subdirectory. It still has its app YAML file for configuration. And then I can add a new app container to that cluster that's a Gatsby site that's then going to evolve alongside WordPress as my developers are making changes to it. But it exists in its own container. In this case, I'm going to edit this name. Oh, I guess I'm not. In this case, I'm going to give it a new unique name that's not app, something like Gatsby. It's got its own Node.js runtime, its own method of using Yarn for installing dependencies, its own build hook, and its own way of serving its final built HTML. So this can go for as large of a microservices sort of configuration that you want. Multiple Java apps, a large variety of different runtimes, as many different services as you want. We actually have an example project that essentially connects all of our runtimes and all of our services, just so that we can provide live code examples for, let's say, Java interacting with Elasticsearch in an application. So we can sort of have our own, we can make ourselves feel a little bit better that we're providing an example inside our documentation that's actually running on a site that's gone through all of these same assurances and tests that I've described here. But I think that right after this, so this is just the pull request where I'm doing those changes that I just showed. Yes. So Git becomes the source of truth for defining the infrastructure and triggering when these test environments are made. But where we really get into the interesting bits is how we can take what we've built for Git and from Git and what we can build on top of it, all the other tooling. So in this case, this is when we get into things like access control and secrets management. And so a lot of that has to do with how we define the environments and then how we define environment variables. And I mentioned a little bit about that already when it came to giving access to services in the cluster. Database doesn't have a password that anybody needs to know about. You just point to the environment variable, you point to the generic internal network location, and everything gets kind of abstracted away at that level. So if I have a developer that adds a new feature on a pull request, I, as the admin, can add that person as a developer to my platform project. That gives them a little bit more access to debugging information about the environment tied to this pull request. But then they don't have any access to any of the other environments. So if I do have a ultra secret API token for my payment gateway that only exists on the production site, I can set it up so that every child environment has no access to it to begin with, but also that if there's any other variables that I'd rather keep secret, this, I think I have it here as an external design agency, they only have access to anything that's in the current environment that they're working on. So no information that doesn't have anything to do with the task at hand. And this isn't anything that I have to build myself in any of the GitOps tooling that I mentioned in the first couple slides. This is kind of all built into our own control and abstraction over what a branch is in relationship to what an environment is when you tie it to an external integration like this. Each of these environments still gets the production data, and at any time that a developer's working on some new feature on an environment like this, we can resync that production data at any time because our API is pretty flexible in that way to allow you to like resync code or just data for those environments. Let's check in on the thread here. So this is, I don't know, in my opinion, it's pretty nice. Like I'll be honest that when I started with my company, my web development experience was pretty minimal. I came from a Python programming background in academia. So coming to this way of working, I've always been maybe surprised, but like a lot of validation that comes with our platform working like this, I guess. It's very easy to try new things out in it to only vary slightly from what I was trying before on a production environment and continue to be able to see, this is what I did wrong with my infrastructure. This is what I need to revert on my production environment. All of that being like really highly visible and kind of at the right level of abstraction has been really nice to play with. And the next thing that has become really interesting for me is when we get back into what I talked about before, this fleet conversation. So I have 100 Java apps or 100 WordPress apps out there. what do I do to kind of what's some bulk tasks? I have a developer who needs access to a particular environment on every single one of these sites. Or more commonly, I need some machine user to have access on each one of these environments, on each one of these sites to run some action like getting updates on my dependencies. Like, how do I do that in an efficient way? Obviously, it's going to be through our API. And so that's what comes into our fleet management sort of story at Platform, where we can do things like keeping these projects in sync with a central code base so that they can get new features when they happen upstream, triggering dependency updates or having them happen automatically in the background, and then using sort of how projects are isolated in the way that I've shown you here in combination with the API to sort of come at a pretty cool middle ground between the multi-tenant, single tenant discussion. You know, if I'm building a site as an agency for one of my clients, it's great to be able to control when things redeploy, when updates happen, dependencies or otherwise, or infrastructure, or getting new features that one of my developers has done, adding Elasticsearch to the upstream. So now it's on all the clients. And that's great for this really widespread control, but our projects are still isolated as far as the API is concerned. So if that client has a developer of their own that's going to be working on that project, they can still open a branch and make changes to that site and not really break any of this control that's happening right here. And that to me seems to be the interesting thing of something I really wouldn't want to try to re-engineer myself with some of these other GitOps tools to build up a process like this. And so that's what we have at Platform. Past this graphic, maybe. So I have that same repo that I was showing you before with pull requests, but this now becomes the upstream code base that I can seed hundreds of other projects out there in the world for my clients from. I can open branches on this particular repository and make changes, but like I said, so can they on their individual project and not really run into each other. They still can have a pretty customizable experience there. And the way that we open that up through our API is we have this relatively newer feature called source operations. So it's here where I can do things like pull from that upstream code base. So this is now a committed command on my application container that essentially creates a new endpoint in addition to our existing Platform API that can do things like git pull from that upstream and merge into a development environment, run all my tests, and then alert me that that upstream update occurred, and I can go into that environment and test it before I merge to production. Or in this case, I created this update deps endpoint that, again, because this just happens to be WordPress, I can run composer update and then commit to that project. And that becomes an important thing because any activity on a project is entirely tied to these commits. If I save something to a mount with write access, that doesn't do anything for my deployments, and that doesn't end up a branch to whatever the parent of that environment is when it gets merged. None of these things that aren't tied to a commit event result in any change in the infrastructure. So I need to replicate that across my fleet to do something like, hey, I have 100 sites, update your dependencies, or every day at 2 a.m. UTC, update your dependencies using the endpoint that I've defined. So I can schedule that as well, and it'll just continue to just update that build image that I have on a separate environment, or I was going to say, or on your production environment, but I probably wouldn't recommend putting this endpoint as having any access to your production environment. But we still have checks that can run in this command. Like you can have an if statement that checks an environment variable that we have in all of our application containers that's called platform branch to say, if this branch isn't master, or if this branch is, update, it's called update deps, and it's a dedicated environment just for this action, we can do that and replicate that across our entire fleet of sites. Oh, so here's the example of exactly that. So this would be another endpoint here that updates the upstream. So I have another environment variable that I can initialize on any project that I define that might be in this fleet of Java apps or whatever it would be. It's called upstream root. And periodically, or every time I trigger it from some major control board, I can trigger this update upstream operation and control what that final build image looks like. And yeah, I hope I didn't go too fast. That's kind of what all I wanted to go through demo-wise. I have a few windows open here of a prior project running, some links that I can share with you guys, but that's really the quick look I wanted to give you on GitOps at Platform.sh and a lot of the tooling that we built on top of Git. I think that it's a way to develop your apps a little bit more efficiently, leveraging every piece of Git and controlling testing and deployments around what you're already used to working with Git. You make your infrastructure committable and visible and version controlled, just like any other dependency, to get that exact build image that's assigned to that exact commit. And ultimately, I think it results in lowering the bar a little bit of contributors, whether that's just onboarding people and not needing to necessarily recruit people who have this extensive knowledge in Kubernetes or any other tool set that you would maybe need to interact directly with an infrastructure service provider, or just simply try to replicate a lot of what we've done here yourself with a lot of tools together. You can say, here is our Java app. It's using these 3 services, and these are the 3 files that you need to look at to say what versions everything are on. And in most cases, you're probably not going to need to change anything, and you can focus just on the application code. But we come out with a new version of Java or of Redis and Solar, you can branch and try out that new major version on one of the new branches. And it's not a difficult task to communicate to somebody you're working with of how to do that. Change a character on a new branch and test it out. So yeah, thank you very much for listening. Happy to stick around for any questions, and I'm happy to share any resources that you guys are interested in getting about platform and what we do with Java there.
Awesome. Well, thank you, Chad, for that. And if people have questions just while we wrap up here, I'll go ahead and do the housekeeping items now, and that'll give you a little bit of extra time to get your questions in the chat, and we can ask Chad. But yeah, thank you, Chad, for that presentation. Platform.sh certainly does seem to offer some great tools to make it easier to configure and improve project infrastructure. And just so people know, for housekeeping items, the next Jakarta Tech Talk will be happening on April 29th. And Larry Garfield, who is Chad's former colleague, will be back again to present building a cloud-friendly application. So if you want to join and learn key guidelines for building a cloud-friendly application, as well as some architectural options that a modern hosting platform enables, you can sign up using the link that I just posted in the chat right now. And also, we recently launched the Jakarta EE Developer Survey. We hope that you guys will all consider providing your input to help the Java ecosystem better understand the requirements, the priorities, perceptions of enterprise developer communities. So if you would not mind completing the survey using the link that I just posted again in the chat, that would be greatly appreciated. And finally, as usual, if you're interested in presenting your own Jakarta Tech Talk, we are always taking signups. That is the third link I posted. And so at this point, If no one else has any questions for Chad, thank you, and I'll give you a minute for any final remarks. But yeah, thanks everybody for joining us. And if you have any feedback on how you like the Jakarta Tech Talk, by all means, feel free to fill out the survey by clicking the green button. Chad, back over to you for some final words.
Thank you very much. I'm going to go ahead and share some of the links in here. I don't know if I'm going to be cool. That's the article from Larry that I mentioned in my talk there. I really recommend that you go take a look at that, as well as a list of all of our Java templates to give you an idea of what Java looks like on platform and our documentation.
Great. Well, thank you again, Chad, for joining us, and thanks everybody in the audience for attending today. We hope to see many of you back again on April 29th for our next talk. Bye, everybody.
Bye. Thank you.